Hey, yeah, personal emergency has taken longer than I expected, so I am not streaming again today. Instead, I took a little bit of time before I had to fly out again to record some stuff. So, um, hopefully, it comes out pretty well. I guess we'll start. Where we left off for the most part, with a few changes. I actually did some stuff I was uh, while I was off and added some stuff. So we've got this nice little, uh, pretty small control flow graph for the start. You see it does the call here and then pushes our uh, return code for exit process. And it does a couple of things right here that we haven't been able to get rid of yet, but that's what the first thing I want to do today. Same for this. Um, we've gotten pretty far down. This one I think I'm just gonna leave for now. I've got an idea of something I can do for that, but for now I'm just gonna leave that. And then we've got all these DX XORs, which are problematic. That's like the biggest issue that we have right now. So that's what I want to tackle first. And then we have the call message box and then nothing. It's just a return. So we've like everything that came after the message box call has now finally been like completely wiped out. And so we're in a pretty good place. The main thing that I think I did was that I stopped using this exception handler analyze Python script and now doing an exception visitor. I switched the state stuff from being a bunch of different variables in the unlock visitor class to actually being an enum, using the enum class that Binary Ninja happens to import. And that made things a little bit cleaner as well. And then I just combined all of the stuff that comes to that into a single class. And so this class is actually what keeps track of the state of that. And the nice thing about that is that it now allows me to actually track exception handlers across different functions, because previously I was keeping one state, and that's not going to work when you've got multiple functions that it's going through. So now we've got that. I've been playing around with some extra phases as well. So I think if you come down here, we've got in the jump to, no, maybe it's analyze go to folding. So in analyze go to folding, I've now added this jump to check. And so that's actually what's getting rid of some of these jump tos. See if I have any left here. I might have gotten rid of all of them at this point. Yeah, so the things that were like if no, not an if it would be like a move EAX some value, like something like this, and then it would say jump to the address that's pointed to by EAX minus some large value. And since those are kind of useless, they tend to get removed pretty easily at this point with the jump to stuff. The other thing is I kind of fixed the this part here where it's getting rid of the variables that aren't used. And the other thing that I do here is I verify that it's not a if it's a pop in the low level IL, then I come in here and I double check to make sure that the source is a stack variable when it's doing a pop, so that I'm actually doing a valid pop here. And when I do that, I check to see if the push has any other uses. So if something's pushed onto the stack and then nothing is done with it and then it's popped off the stack, then I just go ahead and wipe it out, because if there's no other use of that variable, then there's no reason to have it on the stack at any point. So right now I'm doing that. I may take this out at some point, because there is the possibility of like a push and then doing something in a function that then modifies that instruction, that register or whatever, and then pops it back off after it's done. But we don't really have that issue right now. So we'll just kind of leave that in there because I want to clean some of this stuff up. So I think we can actually do this kind of same thing for these XOR DXs. And so that's what we're going to do. And that's going to be in the set var field. So we can kind of do the same thing here. Just take that part right there. We won't worry about popping things because that generally won't happen. And we also want this to be higher than phase 1. So that should be okay as well, because the thing here is that if you do a can't type today. So here it's a set var field. Oops, I want to do an operation. Set var field. But if we get the low-level IL version of that, set reg SSA partial. So that's what we want to do here. So then let's see what the dest is for that. So we want the full reg. And let's see what our that's set reg. I want to check that. And we'll check that. So this should actually keep doing this. So if we do queue previous block, where it queues up the previous thing, if we start here and knock this out, it should jump up to here. And then it'll visit this one and knock that one, and then visit this one and knock that one, and just keep going up until it knocks every single one of these. So let's actually see what happens with that. Is it not going to update my... There we go. All right. I also added a, I don't remember if I mentioned this or not before, but I added a key binding. So now I can just do Control U and it runs unlock for me. This still takes a couple of minutes. It's a lot. It's significantly faster than it used to be, but it still takes a few minutes to run. I think some of this is actually... No, never mind. I don't know what I'm thinking. So our first phase doesn't actually do any of the calls. It's just recovering the main control flow that it can find. Once we hit the end of that, we enter phase 2. Shouldn't be too much longer, I don't think. And so in phase 1, we don't really do too much optimization of the control flow stuff still, because there's still some things that could happen later on that we haven't found yet. So that was actually something that caused me to move the possible call analysis to a later phase, because it was relying on the fact that it wasn't in an exception to determine if there was anything executable on the stack at the time of a jump to a register. And there was a certain one situation in which the push of the exception handler address was put on the stack, and then it was jumping to a register before it actually entered the next phase of the next state of the exception handler state machine, where it was pushing fs+0 onto the stack. And because it wasn't doing that, then it thought that it had found a call, and so it would create a call there, and then that just messed everything up. So at this point now, I let it go ahead and run all the way to the point where it can't run anymore, and then it goes into phase 2, finds the call, adds those. We should be getting there real soon, I think. go ahead and close some of these. See if that helps. Maybe that helps a little faster. Close this too. Seems like it does take a lot longer when I'm recording. Which I guess makes a little bit of sense. When I'm not recording, this takes about 3 minutes, I think. Let's go see what we're looking at now. Okay, yeah, we're getting into the axis now. There we go. All right, so we got multiple functions. The downside is we have to move back to phase 1 when we recover more control flow, because we now have to deal with, yeah, look at that, that was nice. All right, it's doing phase 1 on 41,000 now. So yeah, so these were the ones I was talking about earlier, and these will get wiped out in just a moment. So much stuff that it has to do here that it's not doing anything. I think I see the return address coming. Come on, this is taking forever. Yeah, it's kind of fun to watch, but All right, there's the return. Now we're in phase 3, which means that we're wiping out a bunch of that stuff. We got a few more things. So let's go back to here. Let's see what we got. Got the exit process. All right, let's run unlock one more time. Haha, look at that. That got rid of everything. All we have is the call and the call, basically. And that's the parameter for exit process. Let's come here and see what happens. We just have this one comp right there and this EDX. I need to figure out what to do about this. I think the fact that there's a top level compare means that, in medium level, means that nothing is happening there. So I think if we come here, I think we're going to do this. Because if we knock this out, and then this would get knocked out. And that means that this would end up being a jump here. So I'm going to copy the address of that, and then this one will copy this address. Yeah. So we've still got a little bit of go-tos in the medium level IL, and that's not going to go away because we do have all those blocks, but all constant folding and everything gets folded down there. And then we just got these, which are exactly what they would be. And we got that. So I would call that pretty much good. That's pretty awesome. So let's see, what's excuse me. How long did that end up taking earlier? Time elapsed was 580. That's really long for way longer than before. All right, so what can we do next? I think that basically just finished up all of our optimization. So the next thing that we would want to do is, I think we want to make a flow graph. So what we'd want to do is come through here and collect all of these. The one thing that we'd have to want to deal with is, which I don't have a good example for, would be a jump that does like a loop. We don't have that. But that's something that we could maybe hope we process correctly by checking the dominator, I guess. Let's see what this would look like. All right. So we would want to make a new flow graph node. All right, and we want to make our G function our current function. Cool. Let me see. I think we want to say there's something that has, I need to figure out where I specify the address. That's not what I wanted. It's not the flow graph node. That doesn't specify. That has address. Okay. So I think, let's see. Let's just do current basic block. So here, I would want to get this, and I believe this is going to be disassembly text line. Oh no, this is a list. Okay. So then I want to create them. Okay, so what we can do is say for instruction in current basic block, if instruction not in not jump dot lines Here, I need to make my current address. All right, instruct. If instruction 0, 0 equals jump and let's see, I need to see if the jump target dominates. I think. No, I think I need a scene. Let's see, I think I want, if I can remember how to do this, flow graph appends. No, I want to do first M. So what I want eventually is to do this in a double loop. So let's just see what happens here. Oh, this is supposed to be one. Let's see what this actually shows us. Okay. Oh, didn't add anything. Okay. Let's see. Right. It's an instruction text token, so it needs to be .text. So we get that one. Let's go ahead and type some of this up over here. Oh, current address is not going to work. We need header. I'm not actually putting the thing in. Guess we'll just do while true. No. No. We'll try it like this. Oops. This is not going to work very well, but it's a good first try. There's a lot of corner cases here, I think. Just maybe makes them not corner cases. Maybe it just makes them normal cases if there's so many of them. let's just make this. All right, so I think that this might be a little bit better. So kind of keeping track of which nodes are the which basic block correlates to which flow graph node, and if there's not anything, then we want to keep using the same flow graph node. Let me turn on Python. Get some. All right, I think that this should work. Nope. Oh. Hmm. Right. Oh. Yeah, I can't do that at the end. Hmm. Why are there no lines? We printed. Oh, right. I don't think this is gonna wait. Oh! That didn't work. Hmm. That was a bad flow graph crash. We gotta do this all over again, huh? Let's go ahead and close all these. Make another one of these, and maybe not having anything up will make it a little faster. I'm pretty excited about the fact that we got rid of all that extra stuff. The only thing left, I think, to do is maybe come here and do an OR and see if the left hand side or the right hand side is 0 of the OR, then we just knock it out because there's no point. So I guess we can add that and see if we actually even get to it. Let's just even just assume that it's should be simple enough. See how we're going over here. Ugh, still not into. Almost done with the main phase. Yeah, I wish I could do some more optimization and maybe speed this up a little bit faster by doing the XOR thing. Oh, there we go. That was nice. With the XOR DX stuff, if I was taking the set var field one and doing some constant folding on that, I could probably get a little bit of speed up again because it'd be less data flow analysis it has to do every single time. But there's some issues. It's a little more difficult to patch the DX, like the sub-register ones, because of the fact that I have to figure out what the full register is, then find the previous use of that, figure out if that's a full register use or if it's a sub-register use, and then I have to patch the original instruction. It just becomes a headache, and it's a lot easier just to get rid of them completely if they're not used. So it wipes out a lot of stuff a lot faster at the end, if I just leave the unused things. I need to figure this out too. This one particular jump always gets stuck, like left here, and it ends up giving up and going down this one. And I think I just have like a check somewhere, like if it's 10. I bet if I just change this to 20, it'll do it. go back up to the top for some reason. All right. That one's already good. So I think there's one thing left that oh, the ores didn't get, oh, I put that in while it was doing it. Where did that one take? $493, that was faster. Let's see, so go ahead and save off an analysis database of this. Click. All right, now we should be able to play around with flow graphs. Copy this. Oh no, I want this one. All right, so how are we getting sheet append? Oh, that's dumb of me. No, that still didn't fix it. All right, so they all seem to. Okay, 4 should not have an outgoing branch. All right. That's not working so well. So what I want to do then, it's not whether or not it's been in the actually it's in dominators that I want. I don't know if this is actually the case. All right. And look at that. I just need to change the symbols for those. See what happens with this one. Yeah, just gotta get rid of those. Look at that. And yeah, that's not working. I need to actually show the change the function or change the tokens here to be the right thing. But yeah, that's cool. I think this concludes. I mean, I could keep playing with it, but I'd rather go off to do some other interesting stuff. I'm kind of bummed that I'm finishing this up on a recording, but you know, that's the way it is. And also, I guess today's going to be a short episode. But yeah, we got rid of all our knops. We cleaned up our control flow to almost nothing. Wow, that's so much nicer. I just need to clean up those tokens, and that's just some busy work. We've kind of done that before with the flow graph or the control flow call graph thing, where I just need to iterate through the tokens and be like, okay, is this a pointer? Then okay, turn this into show the symbol here instead of man. Although I don't know why it's I don't know why those aren't actually showing. I think I might have to just process them myself. That's probably what the UI does, is goes in and says, are these actual symbols? If they are, then show that symbol with this particular type. But yeah, here's the code for making one of those. The only thing that it doesn't work on that I know of is going to be like conditional branches. I'd have to figure out how those work, but I don't have any of those right now, so I don't need to. And it'd just be more just like another check of I don't know, I would probably actually use the IL so I didn't have to deal with all the different types of jumps. And just say if it's an if statement here, then figure out where those branches go and add those branches. Man, that's cool. So yeah, we have successfully taken a heavily obfuscated binary, and that's like thousands of basic blocks, and converted it into 2. So that's pretty cool. Yeah, so I guess because I've got other things that I need to do, I will call this recording done, and we can try and pick it up on another day. Hopefully I'll have some time soon, assuming that this my family emergency is dealt with soon. I really don't know how long that's going to take, but I'll try to get back onto a regular streaming schedule as soon as I can. Until then, I hope y'all all have a good day and evening, and I'll catch you next time.